So measuring angles and arcs. So if you look at this first slide, we're going to use this first slide to kind of talk about our central angles here. Okay, so if you look at the circle here, and I know that's kind of hard to see it a little bit. It's a little better. So we say a central angle in a circle is an angle that has the center point at the center of the circle. Now you'll notice here that in a circle, an arc is simply a part of the circle. So from here around the circle to this point, that would be considered an arc. That is the intercepted arc of this central angle. Now, if I told you this central angle right here was 115 degrees, the one thing that we know in a circle is if the central angle intercepts an arc, the intercepted arc measure is also going to be the same degree measurement. So in this picture, the central angle and the intercepted arc are both going to be 115 degrees. Now, the other terminology I want to kind of discuss with you is this idea with an arc. We have what we call a minor arc, and we have what we call a major arc. So a minor arc is going to be an arc that is less than 180 degrees. Now, when we're labeling an arc that's a minor arc, we use two letters. Okay, so the two letters in this picture that we're going to use, if I'm saying this minor arc here, we could say that that is arc AB. So you list the two letters and you put a little arc over the letters. Again, the order of the letters does not matter. I could also call it arc BA if I wanted to. Now we know in a circle, if I were to extend this radius and make it a diameter, and I'm going to add another point just so you can have that arc. So arc ABE, we call an arc that's 180 degrees, we call that a semicircle. So semicircle is half the circle. We know all the way around is 360 degrees. Halfway around is 180. A major arc is going to be an arc that is greater than 180. And less than 360. And for our major arcs, we always use three letters. So in this picture here, I could say major arc ADB. Oops, I want that to be an arc, not a straight line. I could say major arc BDA. Since I added the point E, I could do EDB. There's a lot of major arcs that I could name here in this picture. So knowing the difference of minor, two letters, less than 180. Major arc, three letters, bigger than 180. Everybody good with that? Difference between a minor arc and a major arc? Let's do one more thing here. If I said to you that angle ACB is 85 degrees, what would be the measure of arc AB? Everybody agree it's 85? If I said, what then is the measure of arc ADB, that major arc, all the way around from A to B, what would I do to find that value? We know all the way around the circle is 360. So I'm going to do 360 minus the 85. We would say that that major arc is equal to 275 degrees. All I did was I took 360 minus the minor arc of 85 to get that 275. Okay, let's go ahead and move on. Let's move on to arc length. Now, there is a difference between arc measure and arc length. Arc measure is going to be the same as the degree. It's a degree measurement. Arc length would be if I'm taking and let's say I'm putting a string around the circle. If I were to take that string and straighten it out and then measure the length, that's what we're calling arc length. Now, the formula is 2 pi r times theta over 360. The 2 pi r should look familiar to you. 2 pi r is the circumference of a circle. So that's where that's coming from. The theta over 360, this is just the percentage of the circle that we're going around. So it's going to be the central angle that you're using to fill in there. You know, so if that theta is 90 degrees, that's basically a fourth of the circle. If it's 180, we know it's half the circle. Let's look at an example of finding arc length. So on this last slide, we have a circle. They're telling us the central angle is 60. They're telling us the radius is 9. And they want us to find the arc length PQ, which is the length of this arc here. So if we go to our formula, which our formula is arc length is 2 pi times the radius times theta over 360. So let's fill in what we know. What's the radius? Radius is 9, so 2 times pi times 9. What's our angle measure? 60 over 360. Now we're going to put this in two forms just so we understand both forms. The first form is going to be where we leave pi in our answer. So let's everybody do that first. Multiply 2 times 9 times 60, and then divide by 360, and see what you get. Hopefully when you type that into your calculator, you're getting 3, and then we still have pi in our answer. So in terms of pi, we would say the arc length is 3 pi. Everybody get that? Now we're also going to put this in decimal form. So decimal length, let's round it to the nearest hundredth. So on your calculators, you should have a pi button. You're going to take 3 times pi. If we round that to the nearest hundredth, 9.42. And again, we didn't give you a unit of measurement, so we'll just say 9.42 units. It is going to be a length. So you always want to make sure you label your distance if it is a length.